probably noticed that during the course of the day, we've got an awful lot of Marines and Navy speaking. The Marines are always very early, and we just have a lot to say. Speaking of which, next presentation is admitting human error in the workplace, maximizing asset reliability with human factors. David has served as a fighter pilot and commanding officer in the U.S. Marines, so there'll be time for questions. And business unit manager and entrepreneur in private sector industries. From the pressure of combat to unforgiving environments and industry, David experienced a parallel demand for unparalleled human reliability. David has designed and implemented enterprise programs to deliver human reliability in operations where mistakes can be life-threatening, economic disastrous, direct, I think that's a little off, and environmentally catastrophic on a global scale. He has learned that reliable human performance distills to a set of key principles. Out of Birmingham, Alabama, and wife of 27 years, and you were in the Marines, and 2 children. Thank you.
I'm almost afraid to ask how many in the room have actually been on the flight deck of an aircraft carrier before. Raise your hands. Okay, keep your hand up if you've been on the deck of an aircraft carrier during flight operations. Okay, and keep your hand up if you've actually served on the flight deck of an aircraft carrier during flight operations as well. Okay, one remaining. So thank you, sir. I appreciate your service. I really appreciate what you did for me in that environment for taking care of us. And for those of you that either lowered your hand or didn't you raise your hand, find this guy over here and hire him because this is a real example of reliability. I watched this video over and over again doing things like this, and I love watching it every single time because I like cool flying videos and rock and roll music. But a room like this are full of experts that I truly appreciate that see in this video tremendous amount of reliability. And in fact, when you consider the complexity of this system, it's become what is considered the iconic example of high reliability organizations, or HRO, which many of you are probably familiar with. Think about for a moment the complexity of this system that we're looking at right now. That's 200,000 tons of steel, and it floats. Anybody see how many people are on board this thing? Or for those of you that know, how many people roughly are on board this thing? Okay, so there are some detailed folks in the room. Yep, 4,000, 5,000 or so, give or take, depending on the size. 60 some odd aircraft. Per unit, there's about 12 airplanes for about a 200-man organization, given pilots and maintainers. Then you have intermediate level supply, you have the ship's crew, a lot. Good question. I actually don't know the answer to that. Never had that question before. It's got a shopping mall. It's got fine dining facilities and luxurious sleeping quarters. Almost a small city or a small facility. That is a P&ID going 40 knots through the water, give or take. And the thing about it is, though, the difference is that you, on your way to the shopping mall to get a haircut, you have to scramble over that nuclear reactor on the way there. And when you lay your head on your comfortable pillow at night, you're just a few 100 feet away from several 100,000 pounds of high explosive ordnance. And meanwhile, on the deck, as we saw in the video, there's airplanes accelerating and decelerating from 200 miles an hour, all just part of normal operations. What is routine for them in this highly complex, highly reliable system that we learned to study over time. Routine to these guys is something that's not routine to us. Look at this guy in this picture right here. And for those of you that don't realize it, there's a 50,000-pound airplane doing about 200 miles an hour, sending 35,000 pounds of thrust out of the back of that. And look at the expression on his face right now. Do you think he is complacent? Do you think he's just unaware of the risks that are around him right now? Or do you think he's highly competent at what he does and he sees the reliability of this system worth us spending just a little bit of time on today? Yellow coats, for those that you don't know, is a supervisor that's out here on the flight deck. So not as this guy sitting here minding his own business, and he's actually in charge of the operations that are going on right now. Nobody else has had this problem. I think it's a Marine. I think the Navy guys found the controller and rigged it so the Marines would have a hard time. All right, this is also routine. How many, raise your hand if you flew in an airplane to get here through the weather and the ATC and all that other kind of stuff that was going on. I did too. I flew on an MD-80 series aircraft myself, and the reason I wasn't able to be here today is because of that piece of equipment. But that is one of the most prolifically used aircraft in air transportation today. The MD-80 series goes back 50 years, all the way with the fielding of the DC-9 aircraft. So 50 years of operations and maintenance reliability and those types of things involved in this aircraft. How many of you are familiar with what happened in 2000 with Alaska Airlines? This is also an MD-80 series aircraft. It's an MD-83. And this was being operated on a regularly scheduled transport flight from Puerto Vallarta, Mexico, up to Seattle, Washington, with a stopover in San Francisco. We're going to find out. Thanks for asking. Shortly after they took off from Puerto Vallarta, the pilot started, or the aircrew started reporting that they were having problems with the autopilot of the aircraft. And they started working with maintenance to troubleshoot. And most of you know that the aircraft are able to communicate with maintenance from wherever they are. So they started troubleshooting the problem with maintenance. As they became just to the west of Los Angeles, the pilot started experiencing problems maintaining pitch control of the aircraft. And I've got a computer-generated automation of what happened, and let's take a look at what happened next.
Alaska 261, we are in a dive here. Alaska 261, taking triple pitch. Alaska 261, taking. We're at a 26,000 feet. We are in a vertical dive. Not a dive yet. But we've lost vertical control of our airplane. Alaska 261. We're at 23.7 request. Yeah, we got it back under control there. Oh, yeah.
What happened was the aircraft plummeted into the ocean because of what was found to be a faulty jack screw assembly, and this was determined to be faulty maintenance that led to this accident. All 88 people on board the aircraft were killed. And when they investigated and found faulty maintenance, let me just tell you for a moment what I mean by that. In the vertical stabilizer of the back of the aircraft, there's a single jack screw assembly that controls the entire horizontal flight surface back there, and when the aircrew are operating the airplane and they actuate the flight controls, it just controls the elevator on the back. So what happened was, during the flight, the jack screw assembly stripped out. They got a full deflection of the entire horizontal tail surface, and because of the lack of control authority that the aircrew had, they couldn't recover the aircraft from the dive that it had fallen into. What they found in determining the investigation was the jack screw at the last lubrication interval had not been properly lubricated by the maintenance technician. This is a picture of the jack screw that would look like probably just prior to installation or off the manufacturing line. And if you'll advance it for me, Jordan. This is the one they actually recovered from the aircraft wreckage. Okay? So pretty straightforward in terms of accident investigation, right? Maintenance technician failed to lubricate it, causing it to fail. Simple failure, personal, human error. But we're going to find out, hopefully in the next few minutes, that there's more to the story. Obviously, tremendous business impact on the environment, impact on the industry, impact on the company, and without saying, tremendous impact on the families that were involved here. However, this is not unique to this industry, every organization, and not even as dramatic, has their story to tell. What's interesting in all these stories, however, is what is actually common to all of them. To begin with, these were routine operations. Secondly, the leadership of the organization did not necessarily see this coming at the time. Their safety metrics were very good in most of these examples. And in fact, those safety metrics and some of the other lagging indicators that perhaps you guys talked about yesterday didn't tell the whole story at the time. Also, warnings, indicators were there available to the leadership of the organization, the leaders in the organization, but they failed to take action based on those. The investigations as a result of the ones that I've just shown to you here today were all determined to be a result of human error, and they were all determined to have been 100% avoidable. So again, good morning. My name is David Wilbur. I did fly F-18s off of aircraft carriers in the Marines. Many people don't even know Marines fly airplanes off of aircraft carriers. My call sign in the Marines was Pony, and if you want to find out the story behind Pony, you're going to have to buy me a beer at the bar later on. I currently work for a company called Vetergy Group, and we use those principles that we talk about in high reliability organizations to operationalize resilience in complex organizations. And my time with you in the next 30 minutes or so is to talk about how human factors, in some of this startling example we just talked about, contributes to an asset reliability type of program. I've already heard a lot of people talk, Sean, Rob, and others this morning, about how this boils down to people. Well, maybe we can unpack that people side just a little bit further in this conversation. And perhaps there's more to understanding this component of human error inside of your operations and your organization that actually changes the way you look at it. I hope to leave you with about 5 principles that you can take back to your operation and apply them in your workplace and in your leadership of the organizations that you do lead. And I mentioned at the beginning here, as we look at this aircraft carrier operation, this aspect of a high reliability organization. How many have heard of high reliability, HRO? There's a well-written, well-documented academic community of interest out there in high reliability organizations. They operate on roughly 5 tenets. Those tenets are a preoccupation with failure. I like to call it preoccupation with success. They resist the temptation to oversimplify the facts and data that are available to them. They're very operationally focused. They embrace diversity inside of the organizations for reasons you can imagine. And finally, they seek what is known as resilience. And we're going to talk a bit more about that. But resilience means a recognition that there is no such thing as a perfect system. There is no such thing as error-free, and therefore we implement programs that allow us to find errors and intercept those errors before they become catastrophic in nature. The other framework of high reliability organizations is what we call systems thinking, looking at systems, seeing your operation as a system, not a congregation of a bunch of different components and aspects of the operation. And let's dive into that just a little bit here and talk about what we believe to be true. Number one, looking at the system, we see that highly reliable, complex, human-dominated systems have 3 basic domains that you operate. There's nothing new here. You've all heard this. Asset or mechanical reliability, largely what we're here to talk about this week, process reliability, and human reliability. My assertion to you here is if you look at any one of these components in isolation, you're going to miss out on the big picture, such that systemic reliability, and what we're really after, occurs at the intersection, the relationship between mechanical, process, and people reliability, such that we have people operating equipment of sufficient maintenance, of sufficient fit for purpose within a process that we get predictable, reliable, and safe results. And if we don't, we should expect to get unpredictable and potentially unreliable results out of our system. The other thing that we do in systems thinking is we look at agents and interactions or relationships between agents. And Jordan, as I was getting ready to come speak here at this conference, told me, don't put up in his guidelines for speakers, don't put up slides with a bunch of text and hard to understand complex. So here's violation number 1. And what I want to do here is build a picture for you relatively quickly, and I don't want you to necessarily even be able to see what's on the chart. What I want to explain to you is what I mean by seeing agents and relationships and interactions between agents in a complex system. This is an example of what we call a cause loop diagram. Anybody heard of cause loop diagrams, system thinking? Okay, great. Maybe you can help me out. We're looking at operating discipline within an organization, getting it right the first time, every time. And as we start and look at this relational looping diagram, we see assets that get deployed and developed and deployed in an environment in order to achieve the core competence of the organization. We see the ability to increasing the ability to understand the normal and abnormal modes of operation for that equipment. We then can increase our understanding of the policies, practices, and procedures that need to be written in order to operate and affect that operation. And then we can understand the task and the condition and the standard under which human beings need to operate that equipment. And I'll go ahead and build out the chart just a little bit here. We have the domain of asset reliability and integrity. As we deploy that, we operate and maintain it. It breaks down at certain times. We have potentially unplanned maintenance involved, and we repair and we renew as required in our life cycle asset management strategy. And as we continue to build it out, from each one of these components, or the risk management, we can identify the hazards, mitigate those, and provide process information required to operate the equipment. On the process reliability, with those process and procedures, we can ensure compliance. We can measure performance in order to do analysis, and we can continuously improve the process of the system. On the human reliability, with task understanding of the job task, the conditions and the standards by which people need to operate, we can build competency and competency management systems. We give people the ability to interpret, improvise, and operate the equipment in a certain level of performance. And as operators are performing, and perhaps an error sneaks into the system, it may force, and it would, in this case, increase a potential unplanned disruption to our process that we can study through failure analysis and incident investigation and process modification. So, big squirrely chart, violated the rule. However, what I want you to take away from this chart is you don't operate a linear set of equipment and components. You operate a complex system. And when you understand the complexity and the relationships between these, it starts helping you understand why when you do something in one area, it squirts out completely different on the other side of the organization. Or perhaps when we do things with one intended result and we get something different, we can start to understand through causal relationships why we're getting the outcomes that we are, so that we can apply interventions and strategies in order to improve that. So that's this notion of systems thinking. And what we're here to talk about is over here in the lower left-hand side of this chart is in the human reliability, this aspect of human and human error, as I'm going to assert to you later on, that is actually a product of this system, not an errant individual inside the system. In order to do that, I need to do a demonstration. Anybody recognize this guy? This guy's a scientist named Robert Bahraini, and he actually studied, he was a physiologist back in the 1800s, and he studied the vestibular system of the human body in order to understand vertigo and things of that nature. And Robert Bahraini actually pioneered some science that is still used in understanding human performance today. And now I'm going to do a demonstration for you, but I know there's somebody in the room that always wanted to be a fighter pilot. So now is your chance to be a fighter pilot for just a few minutes today. Can I get a volunteer? You're up? Okay, come on up here. What's your name, sir? Doug. Okay, Doug has decided to be a volunteer. Kill that video for me back there, Jordan. Or advance the slide. Now, Doug, any medical conditions you need to disclose ahead of time? Okay, good. Now, So what Bahraini was arguing was how we perceive the environment around us had a lot to do with the vestibular system in our inner ear in studying vertigo. And the reason that conveyed into piloting world is because obviously sensors and weather and things like that sometimes start to impact the air crew's ability to perceive the environment around them. And so Bahraini invented this chair where he would isolate some of the sensors input to the human being in order to understand those outcomes. So Doug, can I take those glasses off of it? And we're going to do a quick demonstration of what we're talking about here with Doug. And first thing, Doug, I want to explain to you, this is your high-performance aircraft that you've been waiting your whole life to operate. And here's how I want you to operate this thing. When I'm going to turn the chair, this is a swiveling chair. Let me demonstrate. Let me scoot you out just a little bit. Pick your feet up. Okay, now we're going to have you, hold your feet out like that. And you see the chair goes side to side. Now put your hands out like this on your knees and point your thumbs straight up. Now what I want you to do is as the aircraft starts to maneuver, I want you to apply your pilot input in the direction of the turn, which means just as it's there you go, practice. Okay, good job. So now as the chair turns, Doug, you would point both your thumbs to the right, hard to the right. There you go. Okay? Now you're stopped. You see how? Well, this is going to be interesting. Doug has already failed. Okay, so now we're going back. Okay, there you go. Getting better? Okay, good. All right, now we see how Doug is going to operate his equipment. I'm going to ask you to put these blindfolds on and then put these on over your head and as you're over your ears. And Doug, do the best you can to block out all the light that you see in the room. Now, while Doug is getting ready, in military training, we call this the spin and puke. And there's a reason for that, and there's a reason Jordan put me on here just prior to lunch, and for those of you that I see you getting nervous that have been to SeaWorld recently, they have an area called the splash zone, where you are happen to be in Doug's splash zone right now. Now, Doug, remember can you hear me okay, Doug? Now, I'd ask from all of you, keep the noise down as low as possible. Let's observe Doug, and I want to see what happens. Doug, I'm going to ask you to put your feet up, maybe cross them over, thumbs in position. Are you ready? Ready to fly your equipment? I'm going to scoot you forward just a little bit. Hold tight. Okay, here we go. Let's see what happens. Okay, take the eyelet or take your stuff off. Go ahead and pull up the blindfold. You still pointing your thumbs around. How you feel?
A little dizzy.
A little dizzy? All right, sit right there for a minute. Now, what from the guys, because many of you couldn't see in the back of the room, what did you see happen? Somebody up here tell me what happened.
He wasn't quite done rotating yet. He thought he was stationary.
Okay, he thought he was stationary, so he put his thumbs back up. And then when I stopped him, what happened? He actually turned the other direction. Now, this is all because of the vestibular system in your body. However, what I want us to highlight from this, how you feeling? You okay?
I'm good.
Okay, you can go back to your chair then if you want. What I want to highlight this from is that we were the designers of the system. We set this thing in place. We gave them a piece of equipment to operate. We gave them a procedure to do, point your fingers in the direction, operate your equipment. And in doing so, Doug made a mistake. He made an error. Now let me ask you this, how much of that error was Doug's fault? Doug knew what he was supposed to do. He was well-intentioned when he set out to do it. He understood the way the equipment operated, and yet it produced an error. He pointed his thumbs in the wrong direction. So let's just use that as somewhat of an entertaining example to illustrate a few points that I want to highlight. So get out your paper and your pens, and here are your 5 applications to take home with you on the understanding human error in your operation. Number 1, error is ubiquitous. Now, I always use that word, even at the advice of my colleagues that say, what on earth does ubiquitous mean? And I just get to say it, and nobody else, I don't ever get to use ubiquitous except for when I'm standing up here. What does ubiquitous mean? That means it's everywhere. It's omnipresent. It exists, and there's nothing we can do to fully get rid of it. And as I mentioned in this tenet of high reliability, they don't seek error-free. They seek resilient operations because they understand there is no such thing as error-free. So what we strive to do is not engineer error out of our operations. We put programs in place in order to recognize error and account for that error before it becomes something catastrophic. There's a myth that highly educated, very experienced people never make mistakes. Does anybody believe that that's true? There's another myth, or there's another belief that errors typically happen at the shop floor level. Is that fully true? Absolutely not. Let's take a closer look. So when I say resilience, what I mean to this, and you guys are all engineers, so don't pin me down too much on my definition of resilience, but what I'm talking about is operational resilience. And what I suggest is you have a system designed to perform at a certain level of performance, and a disturbance occurs called an error. And what we're mostly interested in is how the system responds or reacts to that error. Most of us took engineering. We understand there's three basics. One, responses or reactions or post states to the disturbance, which is collapse, not what we want. Ductile means we respond, however, we don't come back to the original position, or in this level, or in this case, level of performance. And a robust response, which means we're able to return to the original state that we were in, or operating performance. With the human error, because of its ability to become a resource for us, we actually have now an opportunity for what we'll call adaptive operational resistance, which means if we have systems in place that can recognize and respond to that disturbance in our system, it actually presents a learning opportunity for us, such that if we learn from and adapt our system over time, we can increase in performance, our performance in response to a disturbance in the system. Makes sense. The question is, how do we identify, measure, and improve the adaptiveness of our system to respond to that? Here's number two. Error is a product. I mentioned that earlier as we were talking. If you believe this to be true, and you saw what happened to Doug up here, if we see error in our operation as a product of the system and not this unreliable Doug guy that never does what he's supposed to do, it gives us a much richer opportunity to not just discipline Doug, retrain Doug, do something like that ends up being boring. It gives us an opportunity to more deeply understand our system and become adaptive in nature in who we are. We use what we call the operational juncture in order to put some science behind what I just said. And an operational juncture is meant to describe that, number one, the smallest unit of analysis in human reliability and human performance is decisions that we make and actions that we take. Doug was up here spinning around in circles. He made a decision. I'm supposed to point my thumb in the direction. I took an action. He pointed his thumbs in the direction, and it was wrong. It wasn't the one that we wanted. Let's put it that way. It wasn't wrong. It was just not what we were after. And if we start to analyze these decisions and actions that occur within our operations, we see a taxonomy start to form around this that we can study and analyze and data trend and everything. And the taxonomy we use involves four primary groups, which are we call the people, starting from the upper left. The people, which involves individuals and crews, which the individuals, their psychology, their physiological capability, their strength, their anthropometrics, another big word. The crew makeup, those types of things. The job, how is work controlled, and what type of equipment, what type of workspace, what type of information. The leadership, how is supervision performed, what are the leadership functions, and finally the organization's management systems and culture of the organization. And what it means is how many of those things up there are under the direct influence of Doug in this case? Very few of them. Most of those others are pieces of the system that we put in place, and so therefore, when an error comes squirting out the other end of our system, we ought to blame the system and not Doug. Or, if we do, doesn't mean Doug's not have some accountability or culpability in what happened, but it gives us a richer opportunity to learn and adapt our system over time. Number three, error is a resource. Well, that's what I just said. If we go in and look at decisions and actions that occur both at various tiers and levels of the organization, as well as over time, we can see that error gives us an opportunity, as we just mentioned, to learn about our system and improve our system. so that when a decision or action is taken, it doesn't have to be doesn't have to present itself as an incident or an accident. It could just be a decision that we weren't after. And we can look back inside of the system at a network of interconnecting operational junctures or decisions and actions informed by all that stuff. It gives us an opportunity to learn and improve our system. Here's my recommendation to you. Those who control people that do root cause analysis inside of your organizations, go home to them next week and say, I will not accept human error as a causal finding in a root cause analysis ever again. That's unsatisfactory in our world. A human error or performance error is where the investigation starts, not where it stops. And that's what you should demand of your people as well. It requires enlightened leadership in order to even embrace the types of things that I'm saying. And I don't mean leadership of the plant or leadership of the business, or I mean the body of leadership that leads this organization has got to come to a fundamental understanding of human factors inside of your operation and be willing to dig deep down into the dark, murky, abstract pieces of culture and leadership in your organization so that new conversations start happening framed around a new vernacular based on a taxonomy, and you start actually being willing to have conversations that previously maybe weren't allowed inside of the organization. And last but not least, when we stop blaming the Dougs in the organization for making mistakes and we look at the system through a causal analysis methodology and human factors, using a taxonomy to help us quantify it, data code it, and study it, what happens as a result of that is the emergence of the culture that we're looking for. The emergence of a culture that values safety, emergence of a culture that values doing it right, the emergence of a culture that values those things, and in particular, a reliable culture, a culture of excellence. Now I want to share a quick story. Well, I want to finish this story. So when we look at this Alaska Airlines and this pesky Doug, in this case, sorry Doug, you just happen to be the guy now. It's your day. This Doug that didn't made a decision not to lubricate that jack screw. What we find out is a whole lot more going on here. First off, Doug couldn't actually see the jack screw in order to lubricate it because of access panel, bunch of difficulty in access for maintainability on this aircraft that made it difficult for Doug. The other thing is that as this aircraft was fielded, the time between lubrications was set to be 350 hours. What happens when you have to lubricate the jack screw? That's a question. Anybody? You have to take it off the flight line. What happens when it's not on the flight line? It's not making money. So they increased the interval to 750 hours, then they increased it to 1,200 hours. Then they took it off a hours base and put it on a calendar-based maintenance card, which caused it to end up in the neighborhood of 2,500 hours between jack screw lubrications. So decisions being made at all levels of the organization leading to this jack screw failing. The same thing happened in terms of an M-play check to check wear on that jack screw as well, extended because of business reasons that ended up yielding a jack screw that was unsafe for flight at the time, with or without the maintenance technician that failed to lubricate it. We see a much richer story in here for the organization and the industry to learn by studying deeper behind what caused those human errors. And finally, I want to share a quick story with you to illustrate what I mean. This picture was taken in May of 2005 because this squadron had performed 100,000 hours of mishap-free flying. That's 27 years without a mishap. Now, a mishap means you killed somebody or broke an airplane. Doesn't sound very good. Sounds like a pretty low bar to try to achieve. But what it means is, well, that had only been done about a handful of times in history in this type model series. The deeper story here is that was me right here 15 years ago, and I'd just been given command of this organization. And shortly after I took command of the organization, we wrote our first schedule, and we started operating and failed on day one. Now, also right before I'd taken over, they'd been ceased to operate because of a logistics and maintenance inspection. The audit said unsafe to operate because of maintenance malpractice, shut it down. Best time to take over, by the way. We wrote our first operational schedule a week or so later, got ourselves ready to go, failed on day one. I went out to the Marines and I had to explain to them why we had failed and what we needed to do. And I walked away from this formation. I realized everybody in this organization was happy that we had just failed. I was the only guy in this organization that cared about the fact that we had just failed. And I went and I told my staff at the time, I said, we're no longer in the business of creating flying hours. We're in the business of changing culture, because this is a failing squadron. 1 year later, after the date that I took command of this organization, we were operating in some of the most intense conflict in the Iraqi campaign, as most of you are familiar with. The squadron at this time performed 8 times the operating specification for this unit over a almost 8-month period with 0 failures. I walked out to a young sergeant on the flight line one day, and I had told him when we got ready to go over there that this was going to be one of the hardest things they'd ever done in their lives. And this young sergeant, Johnson was his name, I'll never forget him, he walked up to me and said, "Boss, you said this is going to be hard. When's it going to get hard?" And I realized multiple times along the way that something different had happened inside of this organization, that we were no longer a culture of failure, we were a culture of excellence, we were a culture of reliability, we were a culture of success. The year after we brought all our parts and pieces and people back at the end of that year, and they awarded us what's called the Robert M. Hansen Award. That is the highest, most prestigious award given to a unit and type model series annually. Now, the interesting thing is we had gone from shut down, incapable of operating, to the most prestigious, the highest performing unit and type model series in 1 year. And we didn't buy new equipment. We didn't retool anything. We didn't implement a new maintenance management system. We didn't write new procedures for maintaining the aircraft, because we had all of those things. I'm not discounting the importance of those. But what we did do, and the only thing that we did do, was address those deep, pesky human factors inside of our operations. We changed culture as a result of that into a new culture, and we outperformed every other organization compared to us. That's what I have for you. Thank you for letting a human factors non-reliability engineer spend a little bit of time with you this morning. I'll open it up to questions, but leave you with a question, which is, how resilient is your organization?
I think we have time for probably 1 or 2 questions. Anybody?
Want to know where I got the chair? It's more comfortable than the ones you're sitting in? Don't know what to ask.
You've got the just before lunch crowd.
I know it. Well, that's why we did it. You know, we didn't want anybody. Okay? That's awful easy. I've never gotten out the hook that easy. Thank you.